Hello students, myself Dr. Sreedevi.A, Associate Professor in Physics, Department of Basic Science and Humanities of Christ College of Engineering, Irinalakuda. I hope you all have watched my previous video. In the previous video, we discussed about important concepts and equations of wave optics. In this video, we'll discuss previous year's KEAM questions from wave optics. These are the main topics which we have discussed earlier. Let us start with the first question, which is a question from 2019 paper. A monochromatic source of wavelength 600 nanometer was used in Young's double slit experiment to produce interference pattern. I1 is the intensity of light at a point on the screen where the path difference is 150 nanometer. The intensity of light at a point where the path difference is 200 nanometer given by. These are the options given. In this question, you are asked to calculate intensity of light produced on the screen. But there is a relation connecting intensity of light and phase difference. But in the question, path difference is given. So, you should know the equation for converting path difference to phase difference. This is the required equation. Then equation for intensity, I is equal to I max into cos square phi by 2. Here phi is the phase difference between waves. We can apply these equations for calculating intensity. Phase difference is equal to 2 pi by 600 into 150. Then we get pi by 2. This is the phase difference. Substituting this value in the equation for intensity, I1 is equal to I max into cos square pi by 4. It's equal to I max into 1 by 2, where cos pi by 4 or cos 45 is 1 by root 2. For the second case, the phase difference is 2 pi by 600 into 200. Second value of path difference is given 200. For this, 2 pi by 3 is the phase difference. Then we can substitute this value in this equation for intensity. I is equal to I max into cos square pi by 3. It's equal to I max into 1 by 4. Since cos 60 is 1 by 2. Comparing these two results, we can write I is equal to half into I1. So the answer is A, option A. I is equal to half of I1. Next question. In a single slit, diffraction of width alpha by a monochromatic source of wavelength lambda, the first minimum of the intensity distribution occurs at an angle. These are the given options. This is a question from single slit diffraction. This is the required equation. A sin theta is equal to n lambda. In the question, it's given first minimum. For first minimum, small letter n is equal to 1. For first minimum, n is equal to 1. Slit width A is alpha. So we can substitute these results in the general equation. Alpha sin theta is equal to 1 into lambda. Therefore, sin theta is equal to lambda by alpha. Theta is approximately equal to lambda by alpha. So answer is A. So first write the equation for secondary minimum in the diffraction pattern. A sin theta is equal to n lambda. Substitute the given values, then you get answer. So moving to third question, which is also from 2019 question paper. The Brewster's angle for air to water interface is. Different options are given. Here you can use Brewster's equation. N is equal to tan I. Refractive index is equal to tan I. Here I is Brewster's angle. N is the refractive index of denser medium. Here the medium is water. You know, refractive index of water is 1.33. So we can write 1.33 is equal to tan I. Therefore, I is equal to tan inverse 1.33. So answer is A. Question number 4. What is the minimum thickness in nanometer of a soft film of N 1.3 that results in constructive interference in reflected light if the film is illuminated with light whose wavelength in free space is 620 nanometer? These are the different options. So this is the required equation. Constructive interference 2 mu t cos r is equal to 2n minus 1 lambda by 2. To calculate minimum thickness, small letter n is equal to 1. For normal incidence, for general case, cos r is equal to 1. We can substitute these results in the general equation for constructive interference. Then we get 2 mu t cos r is 1, 2 mu t equal to 2n minus 1 lambda by 2. 2 into mu, refractive index of the film, it is given 1.3 into t is equal to 2 minus 1. Here small letter n is equal to 1, 2 minus 1 into lambda by 2. Lambda is 620 divided by 2. Therefore, thickness is equal to 119.23 nanometer equal to approximately equal to 120 nanometer. So the answer is B. This is the answer. Question number 5. Which of the following statement is correct? Option A. Light waves are transverse but sound waves and waves on string are longitudinal. Option B. Sound waves and waves on a string are transverse but light waves are longitudinal. Option C. Light waves and waves on a string are transverse but sound waves are longitudinal. D. Light waves and sound waves are transverse but waves on string are longitudinal. And option E. Light waves, sound waves and waves on a string are all longitudinal. The answer is C. Light waves are transverse. Light waves are electromagnetic waves and all electromagnetic waves are transverse in nature. Next, about the waves formed on a stretched string. Waves formed on a stretched string are also transverse in nature. Sound waves are always longitudinal. So, option C is the next question from 2017 paper. In Young's double slit experiment, if the separation between the slits is halved and distance between slits and screen is doubled, then the fringe width compared to the original one will be. So this is question from Young's double slit experiment. So you know, equation for bandwidth beta is equal to lambda d by d. In this equation, lambda is wavelength, capital D is the distance between sources and screen, small d is the distance between two sources. It's given that the distance between sources and screen is doubled. So capital D is doubled and distance between sources is halved. So we can substitute the values in this equation. Then beta dash is equal to lambda into 2d. Instead of d, we can write 2d. Double the value of d divided by small d is halved. So d by 2. Then by calculation we get 4 into lambda d by d, that is 4 times of initial bandwidth. So we can write fringe width is quadrupled. So the answer is D. Next question, again question from 2017 paper. Huygens wave theory of light cannot explain option A, diffraction phenomena, option B, interference phenomena, C, photoelectric effect, D, polarization of light, and E, propagation of light. So first option about a diffraction. Diffraction is a property of light that can be explained by wave theory. Next option, interference. Interference is also a property of light that can be explained by wave theory of light. Polarization of light, option D. Polarization can be explained by wave theory of light. But photoelectric effect can be explained by considering only particle nature of light. So, answer is C. Photoelectric effect cannot be explained by wave theory. It can be explained by particle nature of light. Next question. When unpolarized light is incident at Brewster's angle on the boundary between two transparent media, the reflected light polarized with its electric vector is. So also simple question. The reflected light polarized with its electric vector is in a plane perpendicular to the plane of incidence. You can see in the figure plane of incidence and plane of reflected ray. The answer is C. It is in a plane perpendicular to the plane of incidence. Next question. If a ray of light is incident at a glass surface at the Brewster's angle of 60 degree, then the angle of deviation inside the glass is. Question from 2015 paper. So here you can remember the equation I plus R is equal to 90 degree, where I is angle of incidence. This angle is also called Brewster's angle. R, angle of refraction. Second equation, D is equal to I minus R. D is the angle of deviation inside the medium. In the question, it is given Brewster's angle is 60 degree. So we can write I is equal to 60 degree. I plus R is equal to 90 degree. From this we can get the value of R. R is equal to 90 minus 60 equal to 30 degree. Angle of refraction is 30 degree. Now we can substitute these values in the equation. D is equal to I minus R. So angle of deviation is equal to 30 degree. So answer for this question D. Option D, 30 degree. Next question from 2013 paper. If the intensity ratio of two coherent sources used in Young's double slit experiment is 49:1, then the ratio between the maximum and minimum intensities in the interference pattern is. Options given. Here you can see in the question, intensity ratio of two coherent sources is given, intensity ratio. So you should remember the equation connecting intensity ratio. This is the required equation. I max divided by I minimum equal to root I1 plus root I2 whole square divided by root of I1 minus root I2 whole square. Two values are given. Substitute I1 and I2 in this equation. Then we get 16 by 19, 9, 16 by 9. So answer is E. Next question from 2014 paper. The polarizing angle for a medium is found to be 60 degree. The critical angle of the medium is. So now we should know the equation connecting polarizing angle and critical angle. What's equation? Tan I is equal to 1 by sin C, where I is polarizing angle and C is critical angle. Polarizing angle is given 60 degree. So tan 60 is equal to 1 by sin C, which is equal to root 3. Tan 60 is root 3. So sin C is equal to 1 by root 3. Therefore, C, critical angle C is equal to sine inverse 1 by root 3. So answer option C. Next question. In Young's double slit experiment, to increase the fringe width. This is the question. Options are given. This is the important equation for fringe width in Young's double slit experiment. Beta is equal to lambda d by d. So here it's very clear, beta fringe width is directly proportional to lambda, directly proportional to capital D, inversely proportional to small d. So to increase fringe width beta, the wavelength of the source is increased. Answer is A. Next question from 2014 paper. Light of wavelength 5000 angstrom is incident normally on a slit of width 2.5 into 10 raised to minus 4 centimeter. The angular position of second minimum from the central maximum is. Here we can use the condition for secondary minimum in the diffraction pattern. A sin theta is equal to n lambda. Here small n is equal to 1, 2, 3, etc. Here A is the slit width. It's given 2.5 into 10 raised to minus 4 centimeter equal to n lambda. Lambda is 5000 into 10 raised to minus 10. In the question, see the angular position of second minimum. That's the question part. For second minimum, small letter n is equal to 2. Then by doing calculation, we get sin theta is equal to 2 divided by 5. From this, theta is equal to sine inverse 2 divided by 5. So answer B, option B. Next question. A double slit experiment is immersed in a liquid of refractive index 1.33. It has slit separation of 1 millimeter and distance between the plane of slits and screen is 1.33 meter. The slits are illuminated by a parallel beam of light whose wavelength in air is 6830 angstrom. The fringe width is. These are the required equations. Beta is equal to lambda d by d. In a medium other than air, fringe width is given by beta dash is equal to beta by mu, where mu is the refractive index of the medium. Beta is equal to lambda 6830 angstrom. 1 angstrom is equal to 10 raised to minus 10 meter. So instead of angstrom, we can write 10 raised to minus 10 into capital D 1.33 divided by small d 1 millimeter is given. Writing in meter 1 into 10 raised to minus 3 meter. Then beta dash fringe width in water or fringe width in any other liquid. Beta dash equal to 6830 into 10 raised to minus 10 into 1.33 divided by 1.33 into 1 into 10 raised to minus 3. So here we can substitute refractive index. Answer 6830 into 10 raised to minus 7 meter. We can write the value like this also, 6.83 into 10 raised to minus 4 meter. Here the answer option A. See next question. Light is incident on a glass surface at polarizing angle of 57.5 degree. Then the angle between incident ray and refracted ray is. The required equations. Angle of incidence is equal to angle of reflection. Angle between incident ray and refracted ray is equal to I plus R plus 90 degree. In the question, polarizing angle is given. I is equal to 57.5 degree. This is also equal to angle of reflection. Now the angle between incident ray and refracted ray is equal to angle of incidence plus angle of reflection plus 90 degree. It's equal to 57.5 degree plus 57.5 degree plus 90 degree equal to 205 degree. Answer B. Okay students, so these are the previous year's questions from wave optics. There will be 3 or 4 questions from this module. If you take minimum effort, you can score full mark from this session. Wish you all the best. Thank you.